Okay, so here's the ladder. Okay, here she is climbing said ladder. Okay, she's got some backpack on. Okay, so obviously she's applying some force to climb up the ladder, but it doesn't tell me what that force is. And she's climbing some distance up the ladder, and that distance up the ladder is 5 meters. So how much work does she do? Applies a force of something, we don't know what that is. Travels a displacement of 5 meters. Okay, so before I can figure out how much work she does, I need to figure out how much force she applies. I know the displacement is 5, so I just got to figure out what F is. Luckily for me, I know from the stair lab that the amount of work I have to apply to go up a vertical distance is the weight of the object. So the amount of work she needs to apply to the backpack, obviously she's got to lift her own weight up, but we're only worried about the backpack here. So the amount of work she has to apply to the backpack is going to be the force acting on the backpack, so the backpack's weight that she's working against, times the distance. So all I have to do to figure out this force here is find the force of gravity acting on the backpack. So Fg equals mg. So the mass is 10, g is 9.8. Now I get a lot of questions in this unit on whether we should use positive or negative 9.8. Negative 9.8 because it's down, or positive 9.8 because it's not really falling. So you want to use positive 9.8. The reason you want to use a positive 9.8 is because you don't really care about direction. So the nice thing about energy does not really care about direction of things. Okay, up, down, left, right doesn't really matter. And so for that reason, I'm just plugging in the value for this. I'm just plugging in the value of 9.8 because I'm just getting a magnitude. I'm just getting a number. How much is the force of gravity? I don't care the direction of the force of gravity. I just care about the number value. Okay? Sorry, 98 newtons. Okay, so the 98 newtons is the force of gravity. That comes in here because that's how much force she has to apply. And we get 98 times 5, which I don't want to do in my head this morning. It's too early and it's Monday. 490. And the number makes sense. It's going up, which is usually positive. And the force she's applying is up, which is usually positive. So that would give me a positive 490 joules. Remember, positive work is in the direction of motion and negative work is against. Positive work adds energy, negative work takes away energy. So this would be an example of adding in energy here. So that makes sense for that. How much power does she exert? Same thing. Power equals work over time. I know the time it takes is 7.9 seconds. I just found the work. Work was 490 joules. So power equals work over time equals 490 over 7.9. And we get a power of 62.0 watts. Okay, so should be pretty straightforward again. The only